restart YouTube. Okay. Oh, there we go. We have a live preview now. Okay, that's good. If I refresh on my channel and go to here. There we go. Now I have a thing that says I'm live. Perfect. Okay. Sorry about that. I don't know why YouTube is being finicky. Everything on OBS's side and on YouTube's side all said YouTube was connected and running fine, by the way, with the exception of the live preview. All right. Sorry about that. We now have... Hang on, I just got a notification. Put my phone on my charge. All right. We now have our start and end points being generated. So we need to render those out to our scene. For now, I think I'm just going to do a floor layer. Yeah, let's just do a floor layer. And we're going to grab... We need to grab one of our tiles. I didn't paint very many of these, so we need to find one that is... I painted all these, never mind. These were super easy to paint, so... If I select this, Atlas Quartz. What is this indicator? Interesting. Is it terrains? Terrain set -1. No. I am still getting used to their system, so I'm curious what the dot here is. Because it doesn't show on this edge, and it shows only the top one highlighted here. This one's got all three because they're empty on all three. So it makes me wonder if this is something I can use, but not on this, but on another one. So we also need to set up Y sorting. I need to go to... I got distracted. Atlas Quartz. That's what we're looking at. Yeah. Which tile do we want to use? We can change this, by the way. So we can choose a tile we like. It's always this one, by the way. These are shadowed for walls. Every tile but the bottom center is shadowed for walls. So we are going to have to do some... When we do later iterations on our waveform collapse and we start actually converting our typed areas into specific tiles, not here where we're just using this for demo purposes, which we're just going to use. Let's use this. When we start to collapse it later, we're going to have to use the information on neighboring tiles to be able to allocate this. I might just create little like 3x3 or 5x5, whatever we end up going with, probably 5x5, little 5x5 structures, and we'll just drop those in verbatim. But if we get, so if we can set cell, which will take in our chord, And it's going to use a source ID, which for us is going to be this ID of 1. And then we can get atlas chords, which for us, we'll use this tile. So our atlas chords is a vector 2i. So vector 2i of 13, 5. And we don't want to use an alternate. So this will update that cell. So now if we run this, whoops, use this using F6. We have our, again, we don't have a player controller here, so we can't move around. So let's fix that real quick. Sure. Add child node player. Nope, I don't want to do it that way. I want to add my scene. Entities, player, scene. We need to remember to delete this later. Damn it. I keep using this. Run current scene. I need to set my flags. Enabled. Flag. Floating. So we have our starting tile. I don't actually know where a generator other one. Let me. Enabled setter, able to disconnect non-existent single mouse enter. Okay. We need to make sure these are connected before we attempt to disconnect them. Is connected. All right. So let's do this to get rid of those errors, and we want this to be local scene. So we're having some lighting issues with this tile. That shouldn't be working that way. It's because we don't have our global fog. Let's set our player's zoom. Player scene. Camera. Let's turn off our, right, we turn it on through code. Let's set the intensity all the way down then. Energy, 0. Camera. Zoom, default. Well, definitely need light. Oh, it wasn't that. Is that our camera zoom then? We had it set to 1 point, oh, not 17, 1.75. Oh. I wrote that and set that to 0. It helps if I choose the correct scene when I click run scene. Ooh, run level. Run current scene. There it is. Okay. We're getting tiles. So if we remove player from here, and then we update our player scene to go back to that, and 1.75. And then we jump back to our level scene. There we go. Each time we rerun this, it'll get a different coordinate. Sometimes it's off screen. Not much we can do about that in there. But if we add a child node for a camera, we can then go to our 2D, lock it to set the camera's offset. Something like that. And then we'll set zoom to 0.5. Let's try that again. Run scene. There we go. Now we can visualize our paths. Pop back into the script. We're always rendering the same tile, but for now that's fine. Eventually this will go into the chunk logic so it knows how to render itself. At least it'll know this information within the chunk so that we can dump it out to provide it here. All right. If we run through here, we can now compare let's get this. Bar exit equals this. And then we can assign exit here. And then we can use while bar x diff equals exit minus, nope, exit.x minus. If I subtract two vectors, it gives me an xy. That is the linear differential between the two. So I can do diff equals exit minus player start. And then we can do diff is there a, I didn't think so. We can get a length function though. So if we do diff dot length, while it's greater than vector 2i dot 0, we can iterate. greater than 0. So we want to find we want to start tracking each step and how far we are and try not to go past it is kind of the goal for this very naive solution. And so what we need to do is grab if diff.x is greater than diff.y else. So if that's the case, we actually need to know next run. Bar next run length equals, and this is where our variables up above come into play. Do we need a run count delta? We're already adding variability for our run count in our code elsewhere. So let's remove this for now. So we grab our parameters and we do level times min run. We don't care about min runs per level anymore. In our run range, we need to know this is for calculating how many runs we have, so we don't care about that anymore. So we need to get our run range, which is a vector 2. So we want to do a range. We want a random int within range of hallway run range dot x, hallway run range dot y. This will get us how long the run should be. We can then clamp this value. The min should be, we don't want to overshoot. So it's iterating, which means it's non-zero. And the max should then be diff.x, because that's the larger of the two. So this will get us a random value within our intended run range clamped to the maximum that we could possibly go without passing our point. Okay. So we can set this 0 here so that we can assign we still need to know direction. So we can assign our direction here to a vector to I. And we want it to be, so if our x is greater than, we want it to increase x but not y for this run. In our else case, we pretty much do the same thing, but we swap these two, so it's increasing our y instead of our x. And then we want to create a clamp that caps on diff y. This will create a run in a given direction. So now we can introduce our step. And so it will for I in range of next run length. Yeah. This will give us a, let's set run length. This should be an int, and this should be a vector 2i. Halter. Now we should be able to use direction here. We're not using anything that would have direction tied to it. So, all right. We are running. We're building the hallway down a given direction, step by step. So we take our. We need to track. Let's call it var tile look equals player start. The first thing we do before we go into here is we want to tile lock plus equals our direction. That way we don't have to worry about overwriting a previous tile. Yeah. All right. And so that's the first thing we do. And then for each iteration in this map, we want to set our, hang on. If we increment then set, that solves that problem. So let's do this. We can just increment and set in here. So every instance does this. Then we do a chunks.set on tile location for chunk.new h. So that should walk the path we generated, adding tiles. We don't actually do anything with this chunk right now, so. This will iterate through and build a path in theory. Oh, we need to do one more thing in here. We need to update our differential. So the last line here is now we recalculate this based on our tile location. Helps if I run our current scene. I feel like that might be infinite looping. Okay. Diff.length is greater than 0. Print diff. See if it's infinite looping or if it never ran the loop to begin with. Again, it helps if I run current scene. It is infinite looping. Okay. T is 0, -4 as our. I don't like that it is still going. Yep, there we go. Okay. It is getting a distance. So I guess we need to take the absolute of both of these. Oh, also, I need to get dot length. This should be something like 4 as a length. Actually, should be exactly 4 as a length. This should always be positive. It is going to check and see if X or Y is greater. It's going to see X is the greater of the two because Y is negative. There's our problem. So we need to use the absolute value. But the problem then is going to be it's not moving in the right direction. So I need to be doing absolute of each of these in my comparison. It means these need to be using absolute as well when we're calculating how long the run needs to be. I need to set the direction as a directional vector. I want to normalize this, but if I normalize it before, it's going to cause problems. So we should be doing diff.x, then normalized, because this will always be pointing in the x direction. Cannot find member normalized. That normal. Wow, vector 2i's don't have normalized. Normalized. That's wild. Is this output of vector 2? Well, they're normalized vectors, so it should be fine. This needs to be diff.y, and then we will dot normalized. That should work. Can't add vector 2i and vector 2. Can I get dot 2? Can I just cast a vector 2i from a vector? Sorry, can I cast a vector 2 from a vector 2i? Is that a thing we can do? Again, currency. Invalid operands, vector 2i and vector 2 operator in. This is a vector, a variant. Oh. Player start is a vector 2. Oh, player start's a vector 2i. I didn't realize I changed that. This should be vector 2 everywhere. Vector 2i. No, that's backwards. That was correct. I want vector 2i. This should be a vector 2. Everything else should be vector 2i. That is right. Hey, we got a path. So interesting. I mean, it's doing the thing. Let's zoom out our camera a little bit more so we can actually see it all. So let's do a 0.2. And we can re-roll this every time. And we'll get different paths. As we increase our level, so let's move from a level 1 to a level 2. our paths will get progressively longer. We are always doing a run-based, one direction. So let's up this to 5. This is probably going to be off our screen again. Yeah. We should not increase it that much. So if we set this to a 1, and then we add a export var min runs offset. Let's add 2. And let's step this from 8 to 12 down to 6 to 10. And then change our level runs range. And then all that plus min runs offset. How's this look? Again, this is level 5 now. So if we step this back down to a 1, let's increase our offset by 3. It's not doing what we want. Distance, angle. I wonder if these are coming in correct. Let me look it up. Trig, cosine, angle. All right, how to calculate height of triangle based on angle. Yes, give me the picture. Okay, there we go. Sine of A is the distance between A and B. And so we've got an angle. We don't need to know H. We've got an angle though. So if we have a triangle with an angle, this would be our H. The upper one would be A, B, and C. And so sine of this angle is going to be A and B, which in our case would be not what we want. That's correct. Sine A and B, the length of A and B is what we know. That is the distance. Sorry. And then we've got the sine of this angle will give us H. So that sine gives us Y. Which means cosine gives us X. So that is correct. Okay. This isn't correct, though. Because we should be doing exit minus current location. It rolled a step. So on this first instance, it had a distance that was trying to go of 12, which is wrong. And we know that's wrong because our formula says level, which is 1, times the min runs by level, which is 1, times our y, xy, 10. So this is a minimum of 10 plus 2. That's where we're going wrong. Okay, I understand what I'm doing now. This is how long each run is. This is part of calculating how many runs to have. There, that makes much more sense. Okay, so our runs are a little bit longer on the start in relation to it, but they grow slower. So by 10, We get insanely long runs. Maybe we run a smaller number and we do a math.ceil. That means we need to do this as a, let's do 0.5. And we'll do a ceil. This is a 10 run length. Again, I think this might be too long. So let's drop this down. Because again, these runs, ooh, I just realized what's going on here. I think this is a 2 run. Because we're not forcing it to corner every time. Let's find out. So if we take this when we hit the end, before we define our, actually it can be after, that's fine. Let's introduce these as corridors, which means we need to know we are on a tile now. No, we are on the next tile technically, right? No, we just set. So we are on the last tile that was set. So what we can do is we can take all 4 directions now that we've moved away from start, so we don't need to check that. Check for I in vector 2i dot up vector 2i dot down vector 2i dot left and vector 2i dot right. If chunks dot has, nope, not chunks dot has, I plus tile look. So if it doesn't exist in that direction, then yeah, that's fine. Each of these where it branches off to the sides is a step in our, so that'd be a halt, that'd be an intersection for us. We can then label the main tile. So we do this for all of them. And then we would want to do chunks.get tile lock dot, what do we call that field? Value? Okay. Right, I need this to go back here. Value equals I for intersection. So now we've got hallways and we've got intersections. We're not utilizing these just yet, but now each center tile is an intersection where it does its combination point, which would mean that we can iterate through and find all intersections, step 2 out in every direction, and do a run length distance on it. Bound capped by our exit. We need to make sure, I think we're overriding our exit now. Get rid of that. If tile location in the direction, so this gets the next location, and then we check this when you run the same logic. If it doesn't exist, set it. That way we won't override our in tile with a new tile type. And then here, let's do if this dot value equals hull. Dot value equals intersection. Here, let me regenerate that on one that stays on screen. It's still doing the outer bounding. No tile, set. Get value. I think we need to start distinguishing these. So let's set let's do a match on this where we will handle halls, start. Let me change the order of these. Start, oops, end, hall, and intersection. All right, so our start tile and our end tile can just be the ones we were using previously. Our hall and intersection tiles will need to be floor layer. We're using these. So let's do our hall tiles in this. That should be fine. We want to do tile set. Select that tile. 13, sorry, size, yeah, coordinates alias, 13 and 3. So we need to change our chords here from 5 to 3 for hall. And then our intersections, let's do this one, which is 1 and 3. 1 and 3. Am I looking at the wrong scene? This is our level scene. Load current scene. Oh, right. Dot value. Little hard to see. Let's run that again. And here, let's shrink the run quite a bit. Go down to level 3. Oh, okay. Let's shrink this down to a 1 and then change our camera zoom to a 0.5. We've got an in tile right there. We need to be on screen. There we go. In tile. It's weird that's intersectioning like right before it every time. That shouldn't be happening. I can't just, no. Let's alter our zoom to 0.3. It is hard to see. Oh, here's one that's not an intersection right at the corner. So now that we have a path traversal, we can start adding alternate routes and interesting things at all of these locations. We can then create our bounding box. We can mirror it. So let's work on mirroring. How do we want to mirror this? I guess it comes down to how large do we want it to be. I think we want it to be decently sized. So let's bring this down to 2 and set this at 0.4. We want this to be probably something like 5 to 8. I might even bring this down a little bit lower. Now let's leave it at that. Because again, each of these tiles that we're rendering now will turn into a 3x3. The next thing we're going to do when we run this, we want our range int. No, it's range negative. No. I mean, realistically, what we want here is to duplicate this. So we do mirrored bar, mirrored lock equals tile location times -1. This should mirror the location. We don't want that. We want... So if we're going... Here, we'll just run it and see what happens. First off, we need to go to the 2D, and we need to probably take our camera and set this to the center. All right. And then we want to probably down this to 0.25. Okay. And then we do a mirrored location like this. We can then, boom, duplicate this line. We do the mirrored location instead of tile location here and here. And then we want to do the exact same thing here. So we will grab pretty much that, boom, copy. And then we can do that. So chunks has, boom. So we're doing each of the directions, and our indexing is off of directionality plus our tile location. So we then want to find the mirror of this. This is not going to be right. Yeah, I didn't think so. It does start us. We can see our start point in the center, our exit here. And it gives us, actually this gives us an exact verbatim mirror, except we're not adding our intersections like we're supposed to. So we want to grab chunks tile value, boom. We don't have to worry about this check in the other direction. So we can just duplicate this line, and then just times -1. We now have mirrored directionality, which means we have a full area we can build based off of generating a start point and end point. So now we can, and this is stored as reference points in the vector, which means we can continue stepping in any direction. So we can iterate through all of our array objects, all of our chunks. We can find any chunks that are an intersection. So let's remove. So we've got our mirroring. Intersection. How do we want to handle? I kind of like the idea of always going left to right. And it's just a question of whether we're going up or down. So maybe we only mirror on the Y. Let's remove this logic. then change our mirroring logic to only mirror y values instead of x and y values, which would be mirrored location equals a vector 2i of x, comma, tile location dot y times -1. So it just flips our y value. And then we need to do the same here. We get a vector 2i of tile location dot x, tile location dot y times -1. So let's try that. Perfectly mirrored, only in the y direction, which means we're always going left to right. It's just a matter of choosing the paths from there. We can then go back to our 2D scene. Let's reset our camera to a 0.4. We'll say, no, let's leave it at 0.3, just a little bit better. And then we will offset this here. All right. Now we can iterate through all of our intersections and do things at every intersection point on our hallways. Okay. We're about to start an ad here in 2 minutes on Twitch. My back is starting to ache, so I'm going to get up and stretch a little bit, move around, refill my coffee, stuff like that. I am going to just start the ad break a little early on Twitch while I go do that. So give me 2 minutes, 3 minutes, something like that, and I'll be right back. And we're back. All right. So now we have our hallway marching algorithm. This gives us our basis. It doesn't solve our overall problem. We still need to introduce variability, which means branching out from each of our intersections. I think the way we handle this I think what we do is we want it to be I think what we want to do is we want to find points like on this one it would be points like these and connect them. And then find points like these and connect them. And so a structure generated this way should have 3 loops generated in it. And that way we always have the first section as a straight line to an intersection for a couple reasons. I think we need to reduce each leg distance a little bit further. We do these as 3x3s because when we spawn in a guy in a cell, an enemy, we don't want it to be so close to the player start location that they start aggroed. That's something we definitely want to avoid at all costs. We definitely want to leave, maybe we just shorten the first run. And so this is always start location plus a tile or 2, and then an intersection, and then we start branching out from our intersection. So let's do that. Let's do 2 tile run. I think let's increase the lower bound on this. So no. Let's decrease the upper bound. Keep it close to the same, because this is going to be 15 tiles. And each tile is slightly larger than our character. So this is a decent distance. Each tile is 48 by 48, if I remember correctly, which means this is 250 pixels per minimum run, which is 1 second of running. Which is also, okay, 48. 250 pixels is actually less than the vision cone range. So if we run our full project, I broke some things when I was fiddling around with getting this set up. So if we go to the game scene and we re-enable this and we re-enable this, and we re-enable this, and then run it. All right. Each one of these tiles is 48 by 48. So 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. This is 250 pixels across. But we're doing 3 by 3, which means it's actually the edge of the map. Let's see if I can maximize this. How clipped is that for you guys? That's not too bad. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the minimum run length is 15. So if we set it to perfect. Oh, damn. 1, 2, 3, 4, 5. No, each one's 3 by 3. So 3. 1, 2, 3. If we do 1 hallway tile, 1 entry tile. Let's assume we start in the center of the entry tile. So that would be about 1, 2. So if we start in the middle of an entry tile and then do 2 hall tiles before the first point where we can have an enemy, this is what we get. So yeah, let's generate in a 2-tile distance to the first intersection. So we set are there do whiles? Do while? No. That's unfortunate because that would solve this problem. All right, so instead of setting, so this stays the same. This stays the same. We then want to do for I for I in range 2. We want to, actually, I guess we could do, no, let's do it this way. We want to add a tile loc. Plus equals vector 2I dot right. So we, twice in a row, we increment, so we spawn in the player, then we increment and generate a tile. Tile lock as a hall. Twice. Let me switch back to our level scene and run current scene. Yeah, now we always get this short segment right at the beginning. It won't always be an interesting short segment. Maybe we should do one more. And then we'll do a this if I mod 3 is less than 2, else an intersection. Intersection, and then we branch out. And then if we rerun this, intersection, and then we branch out. It just happens to be the next branch in here was a straight line. That will get us, it's hard to see, but we have two hull tiles and then an intersection. And that intersection is the first tile that would be have enemies spawnable in it. And so, and since these are 3x3 tiles, that guarantees if we're always in the center of our start, even if we're all the way to the right, it guarantees, and they're all the way to the left in this tile, it guarantees we have 6 tiles, which is 300, well, just shy, it's 254. No, 6 times 5. So it'd be 300 minus 12. So it'd be 288 pixels, and their vision range is 250, if I remember correctly. So even if they're at the maximum edge, both the enemy and the player of the respective tiles, having these two in the center will ensure the player never spawns in direct vision of an enemy. Even fully randomized, as long as we don't spawn enemies on the start tile or the 2 tiles immediately next to it. That gives us a repeatable entry point, so we don't have to worry about that. Next up, I want to start connecting how we handle these. And the main thing I want to do is I want to have a linear run, always have a linear run in the center. And I want to always have vertical runs on the edges. And you'll see why here in a second. So let's do that. So after this is done on our pathing algorithm, we no longer need our notes on that. So our start logic, our pathing, our connection logic, and then we will do a while diff. Equal to I can piggyback off this loop. I just realized. In every one of these, I can check to see where we should be in relation to start on purely the horizontal and the vertical lines, and check and see if we have a tile there. So if we run our tile location that we have now at the end of this point is our very first intersection. So if we store var starter intersection equal to tile location, we can now use this as our reference point. Every single iteration, we can check there's 3 tiles we want to explicitly check. It's going to be if tile location vector2i tile location dot x. We're gonna have to do all of these. Zero. So this is our purely vertical line coming out. So if chunks, not chunks dot has on this. Then we want to chunks dot set. We can either do, the reason I don't use git here, by the way, because git, if I remember correctly, git will not throw an error. It will set it. So chunks.git. Value for the key. If the key does not exist, returns default or null if the parameter is omitted. So what we can actually do here we could assign. So if we do var chunk equals chunks.get, the reason I don't do this is because when you call get, it will create an entry in chunks for this ID and return it. What I don't know is will it auto set? It doesn't say if it sets the default value into it or if it just sets it as null. So I guess I could do get with this. And then we can call chunk.get, chunk equal chunks.get on this value with this is our default. I want to see if these get assigned or if it just returns. Property key value on a base object of null. Chunk equals chunks.get for new chunk. Interesting. Invalid access to property or key value on a base object of null. So it adds the key, but it doesn't add the default value, which means we need to, if chunk not equal to null, we need to do chunks.set. That doesn't really provide me any benefit though. So I'm going to go back to how we were doing it before. Doesn't provide me any benefit here. It might actually provide me something down here though. Because what I can do is I can do var chunk equals, let me make sure I'm not ghost overriding that. Okay, good. We can assign this now. Get for this value. No, I'm better off just storing this value. I just realized. Var call underscore LOC. Let's see. So doesn't exist. Set underscore LOC. Chunk.new. It doesn't give any intersections. I could mirror this. Now we'll come back to that. This doesn't give any intersections. We can generate out and then update back on intersections later. We can use a waveform collapse to be like, hey, when we're parsing through this and collapsing things down, these are all of our starters. And so all of these locations are going to be hallways. Probably. But if a hallway has 4 directions on it and it's not flagged as an intersection, flagged as an intersection. So we can cause it to collapse. All right. Chunks.has location, set location to hallway. Boom. That should do what I want it to do. Bad example. Try again. Here we go. Hey, there we go. So this will branch out all the way. Technically, I don't think we want this style. So this one might be an edge case where we would want to trim. But if we run it again, this is what we're kind of looking for. This clean separation so that we can branch up. This might be another one where we want to trim, actually. I don't like this segment. The goal here for doing this, let me find a good example of why we want to do this here. The goal for why we wanted to do this is I didn't want it to be a situation where you run to an intersection and it goes up or down, and then you get to the end and, oh, it wasn't here, or I guess the top, oh, it wasn't here, so I just go straight down as a connection point between these. I wanted the option to be able to do this so that we can connect along these lines now, and then turn inter areas like this into POIs so they add some interest so that we can kind of fill it out. This will help with the waveform, adding more starter tiles to it. I also want to do the same going vertical so that we can guarantee a square-ish area. So let's do that next. So the next segment we're going to add to this is going to be an update to our location to set the vector to I for 0, comma, tile. Nope. It's not 0. Also, technically, we're not 0 here. We should be doing starter location dot y. Here, we should be doing starter location dot x. We're locking the other side now. And then we want to do tile location dot y. And then we will duplicate this line and do tile location dot y times -1 so that we do the opposite direction, because again, y goes both. And then in between these, we want to repeat this logic. There. Now we have a fairly square board coming out. We can then use our traversal functions to collapse on our edges. Except we don't always want to do that. Maybe we add a little bit of variability, and so sometimes I'll add these, sometimes it won't. I don't see, the thing here is that if we add this mirroring on how we do this traversal for our hallway, then if you hit an in section and it didn't add this, you know it's always going to be up or down, so you don't need to do any other traversals. So it really simplifies everything. Whereas if we have a straight line out, I guess we have the opposite problem now. If it's a straight line out and it doesn't add forking in either direction, you know it's a straight line. And so with this, if we get a high point, it's always going to be... I guess what I'm getting at is it's never going to be these first ones. And it'll be obvious after you've done this for a few times. So I think the next step here, we should connect these and then reallocate on an active intersection tile a minimum distance away from start as our exit, like branch off of one of these. Actually, here, let's do this. So we've done this. Let's do the naive algorithm. Okay, so we have location setting for center line. So we want to do, this is going to be weird, duplicate this line, update location. No, specifically we update, this one's going to be location.y. .y times -1. .y times equals -1. If I'm doing it this way, though, I need to reset here. Yeah, so this would be location.x equals exit dot x. And then we update and add location.x equals, actually no. So we can create our location, update location.x, reassign, then update our location.y, assign, and then update, let me duplicate this first, and then update location.x back to what it was originally. And do one last assignment. So now we've closed off our access points. We need to turn this into an intersection for sure, though. And so let's make technically when this is stepping. This is going to be weird. Technically when this is stepping, it is setting all of those paths in one loop at one time. So I need to find the point where we corner on each of these. And I think in the waveform collapse, we just say if a hall is surrounded by more than, if a hall tile has more than 2 on it, then it is considered an intersection. That solves that problem. So when we collapse out, then this would be converted to an intersection. But this wouldn't. And of course, this is a starter, so it wouldn't either. And then we need to do the same on locking to our outer bounds on X and Y. Okay, so this is doing its assignment. This is creating an X lock with increasing Y. No, a Y lock with increasing X. This, a Y lock with increasing X. This is our straight line going out. So that's good. Then this handles the vertical lines on both the start and end point of our traversal. And so now when we do this lock, we need to also underscore lock dot, we need to keep in step on our X because we're still traversing our X lines, but we need to lock Y to our exit dot Y. Duplicate this. And then we can repeat that. Y equals exit dot Y times -1. And now we should have a full square on our outer bounds in every iteration. I don't like these though. So we need to figure out a way to clean up the what happens when our final path is offset by 1 from the final line. That might be something we want to do in our waveform on the next iteration so that we can do that cleanup. I think the next step for us is we remove this line and make sure it generates still, which should. Yeah. So now we don't have a defined exit point. It gets allocated as an intersection now, which is fine. I'm wondering how we want to handle double hallways within certain tile distance. Maybe we can collapse those down in our waveform on a final pass or something like that. Or maybe these get allocated into joint POIs. When we have hallways within a certain distance, we can just allocate this entire segment to a room. That might be a good one. It would convert halls within certain bounds of one another into room tiles. Okay, that's something we could do. This would be a corner, although we could intersection that. But now we have an outer bounding box. We can find any tile along these. Add some deviation from it, and then drop it in as an exit. Let's do that as our final iteration in the hallway collapse function. So we fully built our hallway at this point, which is the starter for our waveform to collapse against. We just need to do another pass to do some cleanup on it, which I think will all be handled within our waveform. Actually, we might want to allocate some POIs separately from that and then let our waveform collapse. Yeah. So the next thing we want to do is we want to find a random point within range. So let's do vector 2i with a random point range. So rand int within a range of our x. What do we call our entry point? Starter intersection. Starter intersection. So we've got our starter intersection dot x, and then so that's going to be the leftmost point, and then we need our rightmost point, which is going to be the exit dot x. So this is our range, and then we repeat this, but instead of using that, we use exit dot y times. Oh, hang on. Let's do, because this can be negative, abs exit dot y, and then abs exit dot y. Oops. Times -1. That's backwards. We want this one to be times -1. Come on, there we go. So this will find a point on the outer boundary that we created. So this will be var exit branch. We want to update this tile to be an intersection. So let's set our, it has to exist. We know it exists. So we'll do chunks.get our exit branch dot value equals intersection. Then we will pick a direction to branch off of this. We have very limited options, to be honest, on how we can branch away from this. if I guess we could randomly sample all of the directions until we find one that's empty as our start point. So let's try that. I'm worried that I don't think there's any scenario where we can't find an option because this is an outer tile, so there will always be at least one. So we don't have to worry about it breaking on a while. Realistically, I want to do while here is what I want. Does GD script have the equivalent of a break? GD script break out of for loop. There's a break keyword. All right. So if we run a for I in vector to I dot down. Hey, little kitty, left. This wouldn't be random. This would always be a consistent option. Hey, little kitty, what are you doing? Is my microphone in the way? Here. Let's set this as var ders equals boom left right vector to I dot up I in ders. This will actually give us the key, but we don't really care because then we can do ders dot pick random to get the direction that we want to deviate in. And so we will iterate through it this many times. Each time we'll grab a direction. The problem with this, does this remove? I don't think this removes. GD script does pick random remove items from an array. I don't think it does. No. Okay. So if we then ders dot pop at our location, does this give the gives the actual value at the location? Is there a pop random? No. I guess I can do range. I would need to store it. Range of ders dot length. Maybe dot size. Dot pick random. That will give us a random index. Is range going to stops before in, so it is not okay. So it is not going to hit a size limit on us. Pick random. So this will give us an int. We pop at that location. We need to store it. Let's store this as idx, and then var equals dirs dot idx. So now we have a reference to it, the index, so that we can pop it. So this will actually, will this return our variant? It does return a variant. So let's just do this. So we get a random index within our range. We pop it to get the value. And now we have the direction. We sample the direction, which is going to be chunks.has dir. So if not, so if there is nothing in that direction, then we can run our logic for the chosen direction. In which case, if we store this variable externally, boom, as a vector to I, and then we do dir, we can break out of our loop. So we now have a direction. So we loop until we get a valid direction, is what we're doing here. Once we have a valid direction, we then need to copy some similar logic we did up here. This. We will run in that direction for 3 tiles. And we will set, first off, we need to set tile location equal to exit branch. So let's do this. All right, so we got tile location. We then go in the given direction. And then we set halls until the end, which is now an end. See if that does what I want it. This is telling me that this doesn't exist. We've got a range from our starter X to our exit X, which is 2 or whatever, to wherever the original end was designated at. We're doing a 4 in on dirs here, which might, I mean, it shouldn't. Technically, we want to run this on an initial input of directories.size. So, I mean, we can check var count equals that. Range count. That works too. But problem we're having is this should be fine. This gives us a integer in this range. And then we have, since we're mirroring it, we do a range between negative. I guess what we could do is 0 and that. Let's see if that'll work. Still nothing. It's finding tiles in the middle. This isn't bounding to the outer. We need to know. It's either, it needs to, what we need to do is we need to lock I guess we could do either. I guess what we really want to do is pick a. This is always going to be an external, or nearly always. We can either lock on an axis, or we could let it pick and resolve back using the waveform. I kind of like how this started to go. So let's comment this out for now. And you'll see what's going on. So the problem we're running into is, I'll do that because we want that. We want to comment that line, and then we'll do chunks.set tile location as a new chunk for exit. You'll see what it's doing here in a second. Pay attention to the exit. See how this is on a tile on our interior. If we reroll, there, reroll, there. It's picking a random location in the inner bounds. So if we set this back to what we did here on the lower, it should start working again. So it can be anywhere. So I kind of like that idea because then it gives us more variant options on where it could be. So I don't want it to end up in a spot where it short circuits much of the traversal though. So we do need to make sure when we're generating hallways that they don't get too close to the edge. So let's do minus. What do we set that as? Do we want to bring it in from the edge? I think we do want to bring it in 1. I don't think we need to bring it in much more than that. So -1. Let's do it this way. This is 0. This gets a -1. Actually, this gets a 1. 1 and a -1. And then we want to times 1, -1, pick random. That'll give us the offset we want. And then here we want to +1, and here we want to -1. That'll inset 1 in every direction, so it's always facing the interior. We want to do the latter half on this one. Actually, I'm okay with not doing this, I think. Nah, we'll do it. So this will bound box it within our traversable area. That also gives us the original dimensions that we need to do the navigation regions. We actually have all of those now. Use player start and exit locks to generate points for nav mesh. Do that here in a second. All right, so this will get us a point. somewhere within our area, inset just a little bit, and bounded. We want it to go... We always want it to go away from X. No, because we do want the center line to occasionally be the correct one. So maybe we just let it go. This will generate randomly, and we can use our waveform to collapse around it. Like this one is a weird one. I think this is going to be an outlier for us. I think we might need to do minimum step distances on some of these. This is a pretty good one, because we could turn this into a hall section that goes down to it. Or up. Or technically any direction. I think the best way to do this would be to find the shortest direction and connect it. Yeah, let's traverse in the 4 directions uniformly, going out until one of them resolves to a tile. So can I do that? Yeah. All right. I'll come back to our condition for this on how we want to X out in a little bit. But for now, we just want to take our 4 directions, like we did here. Then we can create we just state our tile location in all 4 directions until we find. So if we do count equals 0, we then walk in each direction from our tile location and then add it to the... Do we want to store these as offset locations? Technically, we could just do chunks.get on tile location plus our... Oh, we need a for loop on this. Here, for now, I'll just do this so I can write it out. So direction times count. That would tell us if that tile, we can do, if. Let's do var chunk equals. I'm not defining chunk anywhere in here, am I? That top level, no. So we get a chunk if chunk not equal to null, and everything at this point is either hallways or intersections. So technically all we care about is has chunk. So if has chunk, we can lock our direction as a vector to I. So it'd be direction equals dirs Again, we're gonna have to do this inside of a for loop. Break. Yeah. And then if we set this to vector 2i dot 0, we can do while direction is equal, or was it 0? Dot 0. Approximately 0. What's the... Is there no equal functions on this? Can we just do that? Equal to vector 2i dot 0. Can't do this on vector 2, but there's equal functions and approximation functions. Those don't exist on vector 2i, so I'm wondering if you can just do integer comparison. All right. So if these are equal, or sorry, while these are equal, which means we're in the 0 case, we loop through, and then when we hit this, we do a do we need ders? We do for direction in directions. These two now become underscore direction. So for each direction in our four possible directions, we check to see which of them is, I don't know what this order was I came up with here. We see if each of those are possibly a tile. If we eventually hit one, or when we eventually hit one, then we break out, and that's the chosen direction. So this will break, and then it'll see this and see that directory is not 0, which will break this loop. And so now we have our traversable. And so we need to, we'll have a, oh, I need increment count, don't I? I need to set count equal to 1, and then, no, count equal to 0, and then count plus equal 1. So this gives us iterations, and so now at the end here, we can do for I in range count. We want to tile location plus equals direction for each iteration. Then we can set if not chunks dot has tile location. It's chunks dot set tile location for hallway. All right, that one was touching a hallway, so didn't do anything. This one got a small hallway. Again, touching. Let me increase this so we have a larger size. Let's go up to 5. Oh, it's a straight line. We might need to bound our, I think we might need to scope our exit location choices a little bit better so we don't get those very straight linear paths. So instead of doing this range, let's run a, we no longer care on this. let's do, it's going to get mirrored, so we can always go positive. 0 is straight ahead, so we don't want 0. Pi over 2 is straight up, so we don't want pi over 2. Which means if we do pi over 4 as our lower boundary, which is going to be pi over 2, pi over 4 is the center. So pi over 8 and then pi times, so if it's 8, it'd be 1/8, 2/8, 3/8. So times 3.0 divided by 8.0. We are doing divide 8.0 on both sides. So let's move that to here. There we go. We no longer need to worry about making sure it's positive or negative or anything like that on our angle, because it will be randomized in our hallway collapse function. It doesn't actually get stored anymore. So this is really just used for endpoint path traversal. So if we now generate, it should give us better squarish shapes every time. Yeah, these are intersection tiles, but I'm wanting to see how we're doing on our hallway. This will happen from time to time, where we end up with a point that is surprisingly close. But again, each of these individual tiles will be replaced with a 3x3, and you can only get about, I think it's like 8 tiles on your screen. So about 3 tiles long is, might be 2 tiles long is the max view distance your character has. So you wouldn't know, when you hit this intersection, you wouldn't know which direction you need to go. And again, this is just our outlined hallway traversal so that we can start our waveform collapse. This is what we're going to use. The next step here is going to be iterating through to introduce our POIs so that we have interesting things along these routes. We need to run our, I think the other thing we need to do is collapse our intersection tiles down. We can do as part of this iteration to get all of the, if you have 3 neighbors or 4 neighbors, you should be an intersection. We can do that for all of our intersections. Then we can use our we can iterate through our loop and find all intersections to determine whether we want to remove an intersection or generate a POI. But we would need to make sure that we do not alter the line of intersections going to our destination. That would be an important one that we would want to avoid. So intersection collapsing. All right. We no longer need this. There's a to-do somewhere in here. There it is. Okay. Let's do this real quick, actually. No. We don't want to do this because we're using 1x1 tiles right now. Which to define types. So each of these are halls or intersections or rooms or exits or things like that. When we actually run through the collapsing stage, a hall turns into a 3x3 hallway. And so the nav mesh needs to be generated when everything is done, which we can do through grabbing all of floor tiles. We can find the full list of floor tiles and we should be able to get the bounding box off that. So that's what we'll have to do. We'll come back to that later, though. Okay. I just realized I missed our ad. But I do need to go to the bathroom real quick. So I am going to take a real quick break. Sorry about the timing on that for our people on Twitch. But I will be back in 2 minutes-ish. Maybe 1 minute. We'll see. Right back. Sorry for the long delay. Some things came up, so I'm gonna have to run and go address those. I'm sorry, but I am gonna have to end the stream early. I will go ahead and trigger a raid on Twitch to move everybody over to, let's find out who's going. Hypnotic. We're gonna hop in there. I'll figure some things out and hopefully be back tomorrow. I'll post any updates that are relevant into our Discord for anybody that follows there. Again, sorry for cutting things short. Thanks for joining me while I was here, and I'll talk to you guys tomorrow, hopefully. Bye.